Course 3, Lesson 116. We are looking at division by zero and figuring out what happens when we take a number and divide by zero. So is there a trend? Can we find numbers that are close to zero to divide by and see if there's anything that's happening consistently? Well, let's try it. What is anything divided by zero? So let's take a number, let's say 5, and divide it by zero. Well, let's not do this by hand. Let's see what a calculator says when we do something like that. So let's try it. 5 divided by 0. We get something that says undefined. Interesting. Well, maybe that 5 was a problem. Let's try it again with something else. Let's try 42 divided by 0. Still undefined. What if we took like 0 divided by 0? All of these are coming up undefined, and the consistent part of what I am doing is dividing by 0. So if I take a number and divide it by 0, it gives me undefined. What is 0 divided by 0? Undefined. Division by 0 is undefined. And if you put some logic into this, let's say that I were to take a pizza and divide it into different pieces. Well, if I divide it for 4 people, that's pretty easy. Each person gets 1/4. If I divide it for 8 people or for 16 people, okay, as we increase the pieces, we still have pieces there, but they just get smaller and smaller and smaller. That's fine. So I can take one whole thing and divide it by a bunch of different numbers. But what if I take one whole thing, one whole pizza, and divide it into 0 pieces? Well, that doesn't make any sense. How big would the pieces be? How many people could eat the pizza? Well, we would want 0 pieces, but we have one whole thing. And we can't just get rid of that pizza. It's still there. And so this logic of trying to divide by 0 doesn't work. It's considered undefined in mathematics. There's lots of different reasons why this is, and we're going to look at 2 major ones. The first one we're going to look at is what happens when we get closer and closer to dividing by 0. So something like this. If I have 10 divided by a number, we're going to substitute in different numbers to see what happens when we get closer and closer to 0, when we approach 0. So 10 divided by 1 is 10. 10 divided by 1/10 is 100. 10 divided by 1/100th is 1,000. And so on and so forth. As we start decreasing this number, as we get closer and closer to 0, and let's see, yep, I did this correctly. And if we were to continue, let's say 10 divided by 0.001, we would get 10,000. And 10 over 0.0001, we would have 100,000. So when I do this, as I get closer and closer to 0, as I go from 1 to 0.1 to 0.01 and so on, I start increasing that number really, really big by the time that we go very close to 0. So as I get closer to 0, I start going to infinity, positive infinity. Well, what if I divide by a negative? So like -1. Well, here we get -10, then we get -100, and -1,000, and the next one would be -10,000, -100,000, -1,000,000, and so on and so forth. So as I get closer and closer to 0 again, but with negatives, I get further and further away into the negative infinities. What this looks like on a graph is something like this. And as you can imagine, here's my 10 over 1 that I graphed. If I had 0.1, so like really, really close here, 0.1 would be way up here. I can't even graph it on this page because it's so far away that I wouldn't be able to graph it, but it's even farther into those infinities. And think about that 0.01, 0.001. And same with the negatives. As I get closer and closer to this 0 point, I get further and further down here. What this ends up seeing is this inverse relationship. as I decrease my number or get closer to 0, I go into the infinities. And this is one way to really realize there's something different about dividing by 0. It's not going to work. Okay, we can't take 10 things and split them into 0 buckets. Okay, so that's one way to realize there's something different about this division by 0. It's not going to act just like a normal division problem. But the other way to realize it is with multiplication facts. So say we took a fact like 2 times 4 equals 8. We can rearrange this to create different division problems using those same numbers, like saying 8 divided by 4 equals 2, or 4 equals 8 divided by 2. I can create 2 different division problems. Well, what if we said something like 2 times 0 equals 0 and did it the same way? Well, I would be saying 2 equals 0 divided by 0, or 0 equals 0 divided by 2. This second one, that works. If I take 0 things and divide them into 2 places, I still have 0 things. That's fine. But how could I take 0 things, put them into 0 buckets, and get 2? That doesn't make sense at all. When we divide by 0, this is especially where we get undefined values, values that don't work with our number system. So let's look at different situations where we don't want to divide by 0. So an x value has to be excluded is what we consider this. We say, I can't use that x value because it would make me divide by 0, and I can't have that happen. So if we were asked to graph the following equation, what x would not work? Well, basically I'm saying if I take 12 and divide by 0, this is my undefined value. Well, what would make this equal to 0? Well, I could say x plus 2, I don't want it to equal 0, so let's figure out what would my x have to be. And I find that subtracting 2, x would have to be -2 for this to force me to divide by 0. So I say, you know what, I have to exclude -2, because if I plug that in, I would end up getting an undefined value. So I say x cannot be -2. So we're going to try that with a few more. I'm sorry these didn't show up on here, but I'll just write them in. I have my first one, 5 over x. So what number could x not equal for this expression? So for this, I'm saying, what would make me divide by 0? In this case, 5 over 0 would just mean that x can't be 0. Because if I plugged in 0, I would get an undefined value. How about 2 over x minus 3? Well, 2 over 0 would make this undefined. So what number for x would make that denominator 0? Well, let's see. If I make it 0, that means that x would have to be 3. So I can't allow x to be 3. Because if I plugged that in, I would have 3 minus 3, and 2 over 0 is undefined, so I have to exclude 3. How about 6 over 2w? Well, 6 over 0 would be undefined, and 2 times 0 equals 0, so w cannot be 0. We're finding these undefined times for these rational expressions and saying, what do I have to exclude? What number do I have to exclude? All right, how about y plus 3 over 2y minus 8? Well, I can't allow that denominator to be 0. So I say, what if it were 0? What would y be? Well, I have to add 8 to each side and divide by 2, and I get y equals 4. So if I plugged in 4 for that y, I would get an undefined value, so I have to exclude it. And just 2 more here, 16 over x squared minus 4. And we have also 3ab over c. Well, this last one is pretty easy. I just can't allow c to be 0. All the other variables, that's fine to be anything you want, even 0, but c cannot be 0. And this last one, just like we've done before, I can't allow this denominator to be 0, so I set it equal to 0 to see what happens. And I say, well, x squared equals 4, and I take the square root. Since this is an equation, x could be 2 or -2, so I exclude both of them and say, if I plugged in a 2 there, it would make it 0. If I plugged in a -2 there, it would make it a 0, so I exclude both of those. So big thing here is we cannot divide by 0. We get an undefined value, and sometimes we have to exclude different values in our denominator so that we don't end up in a situation that we could be dividing by 0. I hope this video helps with your homework and for studying.